Welcome to the DIY Honda Garage channel. Welcome to our diagnostic troubleshooting presentation focused on DTC codes P0202 and P0203, representing circuit malfunctions in the number 2 and number 3 cylinder injectors in the Honda CRV models from 2017 to 2022. These diagnostic trouble codes, DTCs, indicate potential issues with the fuel injection system, specifically related to how the engine computer communicates with the fuel injectors. The fuel injectors are integral components responsible for delivering the correct amounts of fuel into the engine's combustion chambers. Any malfunction can result in poor engine performance, misfires, or failure to start. In this presentation, we will guide you through error descriptions, potential causes, symptoms, and a detailed step-by-step troubleshooting process. Our goal is to help you accurately diagnose and resolve these issues effectively. DTC P0202 and P0203 signify a malfunction in the injector circuits for the number 2 and number 3 cylinders, respectively. The affected components are the fuel injectors, which are essential in ensuring that fuel is delivered to the engine's combustion chambers at the right time and quantity. These injectors are located in the fuel rail and are typically situated on the top of the engine's intake manifold. The role of these fuel injectors is to atomize the fuel for efficient combustion, impacting vehicle performance directly. A malfunction can disrupt this function, leading to engine performance issues. It's important to understand how these injectors interact with the vehicle's engine control unit, ECU, also known as the Powertrain Control Module, PCM, especially in diagnosing these codes. There are several possible causes for the DTCs P0202 and P0203. One common issue can be poor connections or loose terminals at both the injector and the PCM. These connections are essential for the proper flow of electricity, influencing how well the injectors respond to commands from the PCM. A failed injector relay is another potential culprit, as this relay ensures that electrical power flows to the injectors at the right times. Wiring issues can also play a significant role. Damaged, frayed, or shorted wires can disrupt the signaling needed for the injectors to operate correctly. Identifying the root of these issues is crucial for successful troubleshooting. The symptoms associated with DTCs P0202 and P0203 can vary, but typically include issues such as the engine failing to start, which is often the first indicator of injector problems. Rough idling might occur as the engine runs inconsistently due to improper fuel delivery. Drivers may also notice increased fuel consumption, as the engine may compensate for lack of power. Additionally, the check engine light, CEL, will illuminate on the dashboard, alerting the driver to potential issues within the engine management system. These symptoms should drive immediate attention, as they may indicate serious underlying issues affecting vehicle performance. The first step in troubleshooting DTC P0202 and P0203 involves the initial verification of the problem through the use of the Honda Diagnostic System, HDS. Start by turning the vehicle to the on mode without starting the engine. After this, clear any existing diagnostic trouble codes using the HDS, which will reset the onboard systems. After clearing the codes, turn the vehicle to the off position. The next step is to attempt to start the engine. If the engine does not start, crank it for about 20 seconds. Following this, check for any pending or confirmed DTCs again with the HDS. This process helps ensure that the codes are current and need further investigation. In the second step, the focus is on whether the engine starts successfully after the initial troubleshooting steps. This is a crucial indicator of the system's health. If the engine starts, you'll proceed to step 11 for further diagnostics related to the injectors. On the contrary, If the engine fails to start, you will move on to the next step, which involves conducting a relay check. Understanding the starting status of the engine is pivotal for determining the correct diagnostic path, whether it points to a potential relay issue or other component failures. The third troubleshooting step involves checking the injector relay, a key component that controls the flow of electricity to the injectors. Begin by turning the vehicle to the off lock mode for safety. Once the vehicle is off, the next task is to remove the injector relay from its socket. Testing the relay is crucial, as a defective relay can prevent power from reaching the injectors, leading to DTCs P0202 and P0203. Make sure to employ a multimeter or similar testing device to verify whether the relay is functional. This step narrows down potential causes related to electrical flow issues within the injector system. The fourth step focuses on conducting an open wire check on the +B IGP line. In this step, you will measure the voltage between two designated test points, specifically between test point 1, which is the injector relay socket, terminal number 3, and test point 2, which is connected to body ground. Ensure the vehicle is in the off mode and the injector relay is disconnected. This test checks if there is battery voltage present in the system, which is essential for the operation of the fuel injectors. If battery voltage is present, it indicates that the +B IGP wire is functioning correctly, allowing you to proceed to the next diagnostic step. In this step, we check the condition of fuse number A7, which is crucial for the operation of the injector circuit. This 15-amp fuse is located in the underhood fuse relay box. Checking the fuse involves visually inspecting it for any signs of breakage or using a multimeter to determine its continuity. If the fuse is found to be functional, it suggests that there's an open in the +B IGP wire between the fuse and the injector relay that needs to be repaired. Conversely, if the fuse is blown, it indicates a short in the wire that also needs addressing, coupled with a replacement of the blown fuse. This step is vital in ensuring that the power supply to the injectors is intact. The sixth troubleshooting step involves conducting an open wire check on the +B INJ line. This test is performed similarly to the previous voltage check, but focuses on a different parallel circuit. The goal here is to measure the voltage between test point 1, located at the injector relay socket, terminal number 1, and test point 2 that connects to body ground. It is essential to ensure that the vehicle is still in the off lock mode, and the injector relay should remain disconnected. This check aims to confirm the presence of battery voltage necessary for the operation of the fuel injectors. A positive outcome indicates that the +B INJ wire is functioning properly, letting you move ahead to subsequent steps in the troubleshooting process. The seventh troubleshooting step is analogous to the fifth, but focuses on checking the condition of fuse number A10, rated at 20 amps, and located in the underhood fuse relay box. This fuse can have a significant impact on the performance of the injector circuit. As always, you will want to visually inspect the fuse and use a multimeter to ensure it has not blown. If the fuse is functional, it suggests there's an open in the +B INJ wire needing repairs. However, if the fuse is indeed blown, you have encountered a short circuit that must also be addressed. Replacing the blown fuse and repairing the short between the fuse and the injector relay is critical to restoring proper functionality. In step 8, you'll measure the voltage at the FI main RLY-CL line to determine if it is functioning correctly. To perform this test efficiently, turn the vehicle to the on mode and ensure that the injector relay is disconnected. You'll be checking the voltage between test point 1 located at the injector relay socket, terminal number 3, and test point 2 at the same socket, terminal number 4. By confirming the presence of battery voltage, you determine that the FI main RLY-CL wire is in good condition, allowing you to proceed to the next step. This step helps narrow down the specific areas that may require repairs and ensures that power is being directed appropriately within the system. In the 9th troubleshooting step, you will perform an open wire check on the FI main RLY-CL line. Start by turning the vehicle to the off lock mode. Then, utilize the HDS to jump the SCS line, allowing you to monitor any potential fault in the circuit. Wait for a minute after jumping the SCS line. Then, disconnect the PCM connector A. With the relay still disconnected, check for continuity between the test points. The injector relay socket's terminal, number 1, 4, and the PCM connector A, terminal number 5. If there is continuity, it indicates that the FI main RLY-CL wire is functional, and you can look for other issues or substitute a known good PCM. If not, it requires repairing any open in this particular wire between the PCM and the injector relay. In this step, you will check the INJ RLY out wire by conducting another voltage measurement test. Turn the vehicle to the off lock mode and use a jumper wire to connect terminals A and B at the injector relay socket, specifically terminals number 1 and number 2. Once the jumper is connected, use the HDS to jump the SCS line again and disconnect the PCM connector A. Measure the voltage between the last test points, PCM connector A, terminals number 1 and 2, and body ground. If you find battery voltage, it suggests that the INJ RLY out wire is operational. If not, you will need to pursue fixing any open circuit issues between the PCM and the injector relay. At this point, in the 11th step, you will revisit the initial DTC from step 1 to see if P0202 is still present. This is crucial, as it helps discern whether the issue is solely with the number 2 injector. If the DTC P0202 is indicated, you'll proceed to step 12 for further inspection. If it does not show, you will move on to step 20, which may investigate other related issues not directly tied to the number 2 cylinder injector. This step is part of the flowchart approach in troubleshooting, ensuring that you methodically address each potential error before moving to the next component. The 12th troubleshooting step focuses on checking continuity between the INJH2 and INJL2 lines. First, ensure the vehicle is off and PCM connector E, ADP, is disconnected. You will then verify continuity between test point 1, which is at the terminal number 5 of PCM connector E, and test point 2, which is at terminal number 17 of the same connector. If you confirm continuity, it suggests that the respective lines are functioning properly. Leading to step 15 for more advanced diagnostics. If continuity is not present, then an open circuit exists in the INJH2 wire that must be repaired to continue with the injector circuit testing. In step 13, you will inspect the INJH2 line specifically. Start by disconnecting the number 2 injector's 2P connector for safety while checking. You'll be verifying continuity between the designated points. The female terminals of the number 2 injector connector, terminal number 1, and terminal number 5 at PCM connector E. If continuity exists, it indicates that the line to the injector is intact and is functioning correctly, allowing you to advance to step 14. If not, you need to repair the open circuit present in the INJH2 wire extending from the terminals of the PCM to the number 2 injector. Step 14 requires you to check the INJL2 line for continuity, following up on findings from the previous steps. While maintaining the vehicle in the off-lock mode, Ensure that connectors A and E of the PCM remain disconnected alongside the number 2 injector. You will then check for continuity between test point 1, located at the number 2 injector connector, female terminals number 2, and test point 2, at terminal number 17 of PCM connector E. If continuity is confirmed, then the INJL2 wire is functioning properly. However, if continuity is absent, you will need to repair the open wire. If the line checks out, it's recommended to replace the number 2 injector to resolve the initial DTC issue. In the 15th troubleshooting step, we will focus on any potential shorts in the INJH2 line. Start by disconnecting the number 2 injector's 2P connector, and then turn the vehicle to the on mode. Measure any voltage present between test point 1, located at terminal number 5 of PCM connector E, and body ground. If you find voltage, this indicates a short to power in the INJH2 wire that must be repaired to correct the circuit. If no voltage is present, you can proceed to the next diagnostic step, as the wire appears to be intact at this stage. Identifying shorts is key in resolving the issues indicated by DTC codes, ensuring that components function as intended. The 16th step parallels the 15th, but focuses on the INJL2 line. Similar to the preceding step, you'll measure voltage between test point 1 at terminal number 17 of PCM connector E and body ground while keeping the vehicle in the on mode. Detecting any voltage indicates a short to power within the INJL2 wire, which would require you to repair the issue to ensure proper functioning. On the contrary, if no voltage is present, you can conclude that the circuit is undamaged and may continue with further diagnostics. Keeping all injector lines in check is essential for accurate troubleshooting. Step 17 directs you to check for continuity in the INJH2 line to ensure there's no short circuit issue affecting the performance. With the vehicle in the off/lock mode, verify continuity between test point 1 at terminal number 5 of PCM connector E and body ground. If there's continuity, it indicates a short to ground within the line that requires repair. However, if continuity is lacking, you can continue your troubleshooting without immediate concerns for that specific wire. Completing these checks is pivotal to diagnosing the systems affecting the injectors accurately. Step 18 requires you to check for continuity in the INJL2 line, continuing the checks for any faults in the injector wiring. Make sure that the vehicle remains in the off state as you inspect continuity between test point 1 at terminal number 17 of PCM connector E and body ground. If continuity is present, that means the line is functioning properly. If continuity is absent, you will need to conduct repairs on the INJL2 wire between the PCM and the injector. Having the right tools at your disposal, like an ohm meter, will aid tremendously in troubleshooting these issues efficiently. In the 19th troubleshooting step, your focus shifts to checking the continuity of the INJH3 line, which pertains to the number 3 injector. Begin by disconnecting the number 3 injector's 2P connector, ensuring you are maintaining proper safety protocols while performing this check. Measure the continuity between the designated point at terminal number 6 of PCM connector E and body ground. If continuity is confirmed, this indicates that the INJH3 wire is functioning correctly. If continuity is not present, repair the open circuit along the INJH3 wire between the PCM and the injector. This step is important to ensure all wiring is intact and functioning as it should. In this step, you will check the integrity of the INJL3 line, continuing the systematic troubleshooting of the injector circuits. With the vehicle in the off mode, you will measure continuity between the number 3 injector 2P connector at female terminal number 2 and terminal number 4 of PCM connector E. Confirming continuity means the INJL3 wire is operational. If there is no continuity present, you will need to address the issue by repairing the open circuit between the PCM and the number 3 injector. Ensuring all injector connections are intact is crucial for proper engine performance. In the final repair verification stage, the focus is on making sure that all repairs performed have effectively resolved the DTC issues at hand. Start by verifying that all previously identified faults are addressed correctly and that any replaced components are functioning as expected. After verifying the repairs, use the Honda Diagnostics system to clear the DTCs once again to ensure all systems are reset. Finally, check for any new DTCs that may arise, confirming that no further issues are present. This step is critical in ensuring confidence in the repairs and maintaining the reliability of the vehicle. Preventive maintenance is essential in avoiding future occurrences of DTCs P0202 and P0203, as well as ensuring the overall health of the vehicle's injector system. Regularly inspecting the wiring associated with fuel injectors can prevent breakdowns caused by frayed or damaged wires. Additionally, confirming that connections are clean and secure helps maintain proper electrical flow, reducing the risk of intermittent faults that can throw these errors. Engine performance monitoring is also key. Any irregularities in performance should trigger an immediate inspection. Staying proactive can lead to fewer breakdowns and a well-functioning engine. In conclusion, we have thoroughly reviewed the DTC codes P0202 and P0203, which indicate malfunctions in the circuits for the number 2 and number 3 cylinder injectors within the Honda CRV models from 2017 to 2022. We outlined the systematic troubleshooting steps necessary to diagnose and repair the underlying issues effectively. Emphasizing the importance of preventive maintenance can help avoid these codes from manifesting again in the future. By recognizing the signs early and conducting regular inspections, you can ensure the longevity and reliability of the injector systems. We hope this presentation enhances your ability to address these diagnostic trouble codes confidently. Please like and subscribe to the channel. See you next time.